For an 800 amps fuse service, the selection of the correct wire size is critical to ensure safety and compliance with the National Electrical Code. The initial suggestion of using two sets of number 600 American wire gauge wire at 75 degrees Celsius is incorrect. According to the NEC, the minimum wire size for an 800 amps fused service, assuming a 75 degrees Celsius termination temperature rating, requires conductors with sufficient ampacity to carry the load. The NEC specifies that for an 800 amps service, you would typically need either 600 kcmil copper conductors or 500 kcmil aluminum conductors. To understand why the initial suggestion is incorrect and how to arrive at the proper wire size, several factors must be considered. Firstly, ampacity requirements, secondly, conductor material, thirdly, temperature rating, and fourthly, NEC tables and guidelines. Ampacity refers to the current carrying capacity of a conductor. The NEC provides tables, specifically Table 310.16, which lists the ampacities of various conductor sizes based on their insulation type and temperature rating. For an 800 amp service, the conductors must be able to safely carry at least 800 amps. Copper and aluminum have different ampacity characteristics. Copper is a better conductor than aluminum, meaning it can carry more current for a given size. Therefore, a smaller copper conductor can often be used in place of a larger aluminum conductor for the same ampacity requirement. The temperature rating of a conductor indicates the maximum temperature at which the conductor's insulation can safely operate. Common temperature ratings are 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The ampacity of a conductor is affected by its temperature rating. Conductors with higher temperature ratings can carry more current. However, the NEC requires that the lowest temperature rating of any termination point, such as circuit breakers, switches, or equipment terminals, be used to determine the ampacity of the conductor. For example, if the equipment terminals are only rated for 75 degrees Celsius, the 75 degrees Celsius ampacity column in Table 310.16 must be used, even if the conductor is rated for 90 degrees Celsius. The NEC provides specific guidelines and tables for determining the appropriate wire size for various applications. Table 310.16 is a primary reference for determining the ampacity of conductors based on their size, material, and temperature rating. Additional factors such as rating for ambient temperature, the number of conductors in a raceway, and voltage drop may also need to be considered. For an 800 amp service, using Table 310.16 with a 75 degrees Celsius termination temperature rating, a 600 kcmil copper conductor has an ampacity of 470 amps. Since this service requires 800 amps, two sets of 600 kcmil copper conductors in parallel would provide a total ampacity of 940 amps, which exceeds the requirement. Alternatively, a 500 kcmil aluminum conductor has an ampacity of 380 amps at 75 degrees Celsius. To meet the 800 amps requirement, two sets of 500 kcmil aluminum conductors in parallel would provide a total ampacity of 760 amps, which is not sufficient. Therefore, a larger size aluminum conductor or more sets in parallel would be needed. However, it is important to note that the NEC generally discourages the use of more than 3 conductors in parallel per phase or neutral, unless specific conditions are met and engineering supervision is provided. Now, let's address the initial suggestion of using two sets of number 600 American wire gauge wire. Number 600 American wire gauge wire is significantly smaller than 600 kcmil wire. The American wire gauge system is used for smaller conductors, while kcmil is used for larger conductors. For example, number 6 American wire gauge wire has a much smaller cross-sectional area and ampacity than 600 kcmil wire. Therefore, two sets of number 6 American wire gauge wire would not be sufficient for an 800 amp service. To correctly size the conductors for an 800 amp service, follow these steps. Firstly, determine the service current. In this case, the service is rated for 800 amps. Secondly, identify the conductor material. Decide whether to use copper or aluminum conductors based on cost, availability, and other factors. Thirdly, determine the termination temperature rating. Check the temperature rating of the equipment terminals and use the lowest rating. Fourthly, consult NEC Table 310.16. Find the appropriate ampacity for the selected conductor material and temperature rating. Fifthly, select the conductor size. Choose a conductor size that has an ampacity equal to or greater than the service current. Sixthly, consider dating factors. Apply any necessary dating factors for ambient temperature, the number of conductors in a raceway, and other conditions. Seventhly, verify voltage drop. Ensure that the voltage drop is within acceptable limits. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% overall. Eighthly, install conductors in parallel if necessary. If a single conductor cannot carry the required current, install multiple conductors in parallel. Ensure that all parallel conductors are the same size, material, and length. Also, ensure that they are properly terminated. Ninthly, use appropriate overcurrent protection. Install fuses or circuit breakers with the correct ampere rating to protect the conductors from overloads and short circuit. Tenthly, follow all applicable NEC requirements. Adhere to all NEC guidelines and regulations for conductor installation, including proper support, spacing, and protection. In summary, for an 800 amps fuse service, the correct wire size would be 600 kcmil copper or 500 kcmil aluminum, based on the 75 degrees Celsius termination temperature rating and NEC Table 310.16. The initial suggestion of using two sets of number 600 American wire gauge wire is incorrect, as number 600 American wire gauge wire is much smaller than 600 kcmil wire. Always consult the NEC and a qualified electrical engineer to ensure that the correct wire size is selected for any electrical service. Also, consider practical considerations such as ease of installation, cost, and availability of materials. Remember that proper wire sizing is crucial for the safe and reliable operation of an electrical system. Undersized conductors can overheat, leading to insulation failure, fires, and other hazards. Oversized conductors can increase costs and may be more difficult to install. By following the NEC guidelines and consulting with a qualified electrician, you can ensure that the correct wire size is selected for your application, promoting safety and efficiency. Additionally, ensure all connections are properly torqued to the manufacturer's specifications. Loose connections can cause heat and lead to failure. Use the correct type of connectors for the wire size and material being used. Ensure that the conductors are properly supported and protected from physical damage. Label all conductors and connections clearly for easy identification and maintenance. Keep accurate records of all wire sizes, materials, and ampacities for future reference. Regularly inspect the electrical system for any signs of overheating, damage, or loose connections. Address any issues promptly to prevent further problems. Also, it is crucial to coordinate the wire size with the service entrance equipment and distribution panel. The terminals and lugs in this equipment must be rated for the size and type of conductor being used. If the terminals are not compatible with the selected wire size, adapters or other modifications may be necessary. Furthermore, consider the impact of harmonics on the electrical system. Harmonics can increase the current flowing through the conductors, potentially leading to overheating and failure. If harmonics are present, it may be necessary to increase the wire size or use special harmonic filtering equipment. Always use appropriately rated tools and equipment when working with electrical conductors. Wear personal protective equipment such as gloves, safety glasses, and insulated shoes. Follow all safety procedures and guidelines to prevent electrical shock and other hazards. Finally, remember that electrical codes and regulations can vary depending on the location. Consult with local authorities and inspectors to ensure compliance with all applicable requirements. The NEC is updated regularly, so it is important to stay informed of the latest changes and revisions. Subscriptions to electrical trade publications and attendance at industry training events can help you stay up to date. By following these guidelines and recommendations, you can ensure that the 800 amps fuse service is properly wired and protected, providing safe and reliable electrical power for your facility. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer for specific recommendations tailored to your particular application. They can perform a detailed load calculation, assess the specific site conditions, and ensure compliance with all applicable codes and regulations. Also, they can help you select the most appropriate wire size, material, and insulation type for your application, taking into account factors such as cost, availability, and performance. Furthermore, a qualified electrical engineer can provide valuable assistance with the design and installation of the electrical system. They can prepare detailed drawings and specifications, oversee the installation process, and ensure that the system is properly tested and commissioned. This can help to minimize errors, reduce costs, and ensure that the system operates safely and reliably for many years to come. In addition to wire sizing, the selection of appropriate overcurrent protection devices, such as fuses and circuit breakers, is also critical. These devices are designed to protect the conductors from overloads and short circuits, preventing overheating and potential fires. The ampere rating of the overcurrent protection device must be carefully selected to match the ampacity of the conductors being protected. If the overcurrent protection device is too small, it will trip unnecessarily, interrupting the flow of power. If it is too large, it will not provide adequate protection, potentially allowing the conductors to overheat and fail. Always follow the manufacturer's recommendations for the selection and installation of overcurrent protection devices. Ensure that the devices are properly labeled and readily accessible for maintenance and testing. Also, consider the use of surge protection devices to protect the electrical system from voltage spikes caused by lightning strikes and other disturbances. Surge protection devices can help to prevent damage to sensitive electronic equipment and reduce the risk of fires. They should be installed at the service entrance and at any critical branch circuit. In addition to the technical aspects of wire sizing and overcurrent protection, it is also important to consider the environmental conditions in which the electrical system will be operating. For example, if the system is located in a damp or corrosive environment, it may be necessary to use special corrosion-resistant conductors and enclosures. If the system is located in a high-temperature environment, it may be necessary to direct the ampacity of the conductors to account for the increased heat. Always consult with a qualified electrical engineer to determine the appropriate environmental protection measures for your application. Finally, remember that electrical safety is paramount. Always energize the circuit before working on any electrical equipment. Use appropriate lockout-tagout procedures to prevent accidental energization. Wear personal protective equipment such as gloves, safety glasses, and insulated shoes. Follow all safety procedures and guidelines to prevent electrical shock and other hazards. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work safely and correctly. Proper grounding is also critical for electrical safety. Ensure that all electrical equipment is properly grounded to provide a safe path for fault current to flow back to the source. This helps to prevent electrical shock and reduce the risk of fires. The grounding system should be inspected regularly to ensure that it is in good condition. Any damaged or corroded grounding conductors should be replaced immediately. Also, consider the use of ground fault circuit interrupters, GFCIs, to protect against electrical shock. GFCIs are designed to detect small leakage currents to ground and quickly de-energize the circuit, preventing serious injury. They should be installed in all wet locations, such as bathrooms, kitchens, and outdoor areas. In summary, wire sizing for an 800 amp service requires careful consideration of several factors, including ampacity requirements, conductor material, temperature rating, and NEC tables and guidelines. By following these guidelines and consulting with a qualified electrical engineer, you can ensure that the electrical system is properly designed, installed, and protected, providing safe and reliable power for your facility.